Alright, 2.5 inscribed circles. So we did circumscribed circles previously. Every triangle also has an inscribed circle associated with it. And as you can see in the picture here, inscribed means that the circle is on the inside. We still have points of tangency here, here, and there, so there are 90-degree angles over there. So what I meant is there would be 90-degree angles over here, and over here. And if I wanted to prove the theorem that we're going to look at here in a little bit, or the relationship, then that's sort of where you would go with that. So we're not going to prove this one. We've done a number of proofs, but we are going to do some examples that work with it. So if it's an inscribed circle, you do need to memorize sort of this little rule over here, and that would be that for an inscribed circle, the center of the inscribed circle, so this center, is the intersection of the bisectors of the angles. So this line here bisects A in two equal angles. This line here bisects B in two equal angles. And this one over here does the same thing with C. So C is equal, or equally split here. Okay? So you should be able to draw a bisector of an angle. And how do you do that? Well, let's just go through one. So a bisector of an angle, the way that you would do that is with a compass. You would use the vertex here, the corner here, as the center of your circle, and you would just mark a circle like this. So, okay, now you don't need to draw the whole thing. So, oh, sorry. So you would probably just draw an arc that intercepts right there and right there. Okay, so step one was use A, and we're going to call this A as center of the circle, and draw the arc that intersects both. And I guess these are called rays, right? So both rays. Okay. Once you do that, let me see if I can make the size smaller. I can't. Okay. Once you do that, you're going to use this point over here and this point over here. And you will want to create, you're going to use another circle. You have to use the same size. So I don't know if I can do that as well over here. So, but you would put your compass there, and you would draw a circle from that one. And you would draw a circle from that one. And where those two circles intersect, and so again you don't have to draw the whole circle, where those two circles intersect is the point that you're really interested in. So your picture probably would look a little bit more like this. Can't erase too much there, so you would need to draw the whole thing. On this side I can do a little better job. So you would just make sure that you draw two arcs that clearly intersect. Alright, so what did we do? So we used these intercepts, this one and this one, to draw two arcs that also intersect. Okay, and then the line through, so the line through that intersection and A is the bisector. So I just have to draw that line. So the line from A through this point, and you can see it looks pretty good, right? Bisects it, okay? So you should be able to do that. So I wanted you to sort of see that once sort of slowly so that you can work with it. Okay, so the inscribed circle and the triangle. There are several ways that you can relate it. So here's one formula. You could say that the radius of the circle is S minus A tangent half of angle A, and you can do the same things with B and with C. The other way that you can find the radius of this circle would be to say that you find the area and you divide it by S. And if you do that algebraically, you actually get this formula here. So there are two more formulas here that you can work with. So what does this look like then? Well, find the radius of the inscribed circle for the triangle ABC, with A is 2, B is 3, and C is 4, and then draw the triangle and the circle accurately. Okay, so the first thing you would want to find then is figure out which of these two formulas that you're going to use. Well, I'm giving all of the sides, so I don't have an angle. I could clearly find an angle here, but this one is depending strictly on sides. So if I had to find the radius of this circle, I would say I would do s minus a, s minus b, s minus c, all divided by s. Okay, and we know that s is that semi-perimeter, so we need to add all the sides, 2 plus 3 plus 4, and we're dividing that by 2, so 5, that is 9 over 2. Well, then the radius would be the square root of that mess, so I need a little more room here because I need to write 9 over 2 minus 2 times 9 over 2 minus 3 times 9 over 2 minus 4, so I take the semi-perimeter and subtract each of the sides, all divided by 9 over 2. Well, that's just a calculator problem. So plug it in the calculator and it will tell you that the circle's radius is approximately this long. Okay? And then it says draw the triangle, the circle accurately. So I did not show you how to draw a triangle. So here is what it would look like, or what you would do to draw a triangle. If I can get this to go full screen. Okay, got a little impatient there. Alright, so there are 3 side lengths that are given, so you would have to use a ruler here. Usually what I would do is, if I draw 1, so let's say that's 10, then I would just mark the 8 here, and I would mark the, whatever that is, the 6 over there, and then I would, use that as its space. So they just say, there's A, and then you measure from A to B, and then you mark from A to B somewhere, so that your base is nice and flat. Put B anywhere on there. Then mark AC on your compass, and then standard A, sorry, and arc it. So then that means the distance from here to there is exactly that second distance. Then we're going to find that last length. We're going to use BC, and so then the next thing would be to put the compass right here at B and draw an arc. And then that intersection is the point where angle C has to be. Okay, because we know AC is exactly the length that we have over here, BC is exactly the length that we have over here, and AB was our base. And then you draw your triangle. So that is how you would draw a triangle. And once you have your triangle, you can then go work on finding the inscribed triangle, or I'm sorry, the inscribed circle that goes with that. And I have that over here, I believe. Okay, let's see if I have a little more patience on this. Alrighty. Okay, so you have your triangle, and then we're going to pick a corner, and we'll just draw that first arc, draw an arc across each leg. So we're going to find the bisector of this particular angle here. Then we grab our compass, and we mark again both top and bottom, and then we have an intersection over here. So then the line from here to there would be your bisector. So you draw that line. Make sure you go nice all the way into your triangle, because you can sort of see that this circle that's inscribed is probably going to be over here. So you don't just want to finish here. Draw this line so that you can have an intersection here. Okay, then you need to do it one more time. So both of those, stand at those 2 points, draw the 2 lines or the 2 arcs from either of those. Connect with angle, and you can see here that this is why I said extended. There's the center of the circle. Okay? So the center of the circle is right over there. And then construct a perpendicular from the in-center to the side. So we need to create a perpendicular line from there So why do you need a perpendicular line? Okay. And this is maybe the part that's a little confusing. I'll let it finish over here. Okay, so for the perpendicular, we just double marked it over here and then double marked it over there again. So keep in mind that I said a little bit earlier in our notes that you are dealing with 90-degree angles where the circle touches the triangle. So let's go back for just a second. And I actually drew the 90 degrees in here. See, this circle touches right here at E, at D, and at F, and that is a 90-degree angle. So once you find the center of the circle, you still have to draw this 90-degree line, because the radius is the distance from the center out to the point of tangency. Okay, so this one is a little more involved than the circle that circumscribes the triangle, because you easily can find the radius from that one. But now once you have this, that is the radius of the circle. So now we put a compass from the in center to M, and you rotate through, and you get a circle. Now when you guys do this in your homework, it's not always going to be as perfect as this. So don't completely freak out if it's not quite right. You know, if you're a little over here and maybe a little short here, that's okay. If it's completely incorrect, then you need to check your work. Okay? Okay, let's see. I think we have a little bit left. One more example. So we found it. I showed you how to construct the whole thing. So here, you know, you can draw the triangle and the circle accurately. That's something that you can practice. I wanted to show you how else, or I want to show you the second formula that you could use to find it, and that would be this one over here. The radius is the semi-perimeter minus a side, and then times the tangent of half of that angle. Because here we're given C, that's 45. Okay, now unfortunately they don't have either A or B here. Now there's no way to use the previous one, which relied on knowing both or all three sides, so I would need to find C anyway. But if I have C, then I can use this angle over here, because it's the shorter of the two formulas. So the first step here is we're going to find C. And you do that by doing law of cosines. So C squared is A squared plus B squared minus 2AB cosine C. You know all those values other than C squared, so it's 5 squared plus 7 squared minus 2 times 5 times 7, the cosine of 45, and when you put that in the calculator and you take the square root, you end up with 4.95. Okay. Once I know this, I can use the fact that the radius is the semi-perimeter minus that side times the tangent of half of angle C. So I do have to find the semi-perimeter here, which is 5 plus 7 plus 4.95. Divide that by 2. So that semi-perimeter is 8.475. So plug that in over here. So 8475 minus 4.95 times the tangent, and then half of C is a half times 45. And your calculator has brackets here anyway, so you can just literally put a half times 45 in there, make sure you close your parentheses, you punch this in, and you get a radius of 1.46. Okay, now you go draw the triangle and then find the inscribed circle. Please don't try to do this the other way. I mean, I know you can measure 1.46 and draw a circle, but then 5, 7, and 4.95, that triangle has to fit exactly around that circle, so that would not be an appropriate way to construct it. You construct a triangle first, because that's fairly straightforward, and then from the triangle you create the conditions so that you can find the inscribed circle. Thank you.